Hi there. I'm back. We're gonna pick up on page 7 and listen, in this packet, Unit 3 functions. So this one, I actually love doing this. This is once we've determined whether or not we have a function. Let me restate that. Our first skill was determining whether or not we had a function, right? So if we determine that something's not a function in this class, we could literally just take it, throw it in the garbage, or cross it out. We're done with it. If from the ordered pairs you decide that what you have is a function, the next thing we need to determine is if it's linear or nonlinear. In 8th grade, remember we've talked about this quite a bit. In 8th grade, can I help you? Sweet, go. What do you need?
Do you want to record?
Yes, go. What do you need?
minutes.
Okay, I'll be in like 5 minutes. That's Haley. She's cleaning her room. She wants me to come inspect it. I'll go do that in a minute. Okay, so let's get back to it. If in skill 1 you determine that the ordered pairs that you have are a function, we then in 8th grade are going to study just the linear ones. So for now, in 8th grade, we're going to put the nonlinear functions aside. You will be studying those primarily in 9th grade. I'm not saying we're never going to do nonlinear, but as far as like a lot of questioning goes, we're just going to ask questions about linear. So our next skill is, okay, now you have a function. Is it linear or nonlinear? A linear function is a function that will make a straight line when we graph it. So this is not new, but this is the first time we've actually written this down. Can you believe it? All this talk, all this time, this is the first time we're actually formally doing this. I'm hoping that it's all kind of review. An equation is linear. If you're looking at an equation, you know it's linear if it can be written in the form of y equals mx plus b. So if you see something that's written like that, there's no exponents up here, you know it's linear. M is your slope, and b right here is your y-intercept. A table is linear if it shows a constant rate of change throughout the entire table. So if I give you a set of data, you determine if it's a function. I'm then going to ask you to do a little bit more work and see if that's a linear function. And that is, this right here tends to be a little bit more of a trickier skill. So let's talk about these two examples. And the following examples will use functions to fill a table of values and create a graph. Look for any patterns among the functions that are linear and those that are not. Okay, so we're going to make a set of ordered pairs for the equation y equals x squared plus 1. Now, you might already have an idea of what this is going to kind of look like or what it's not going to look like based on some side conversation we had in class earlier, but if you don't remember, that's okay because we're just going to create some points and plot them and see what happens. So what we're going to do is we're going to first plug in -2 for x and see what y becomes when x is -2. So when x is -2, we're going to do y equals x squared plus 1. Be very careful with your calculator on this. So we're going to do y equals, in parentheses, -2 squared plus 1. So when you go to put this in your calculator, if you do not use the parentheses, you're going, look, I'm pounding. It's so important. If you do not use the parentheses, you are going to get the wrong answer. Some of you are going to do it in your head and then you're safer. But -2 squared is -2 times -2, which is 4. And 4 plus 1 is 5. Okay, so -2, 5. I have one ordered pair. So -2, 5 is here, plotted. And then -1. What is y? Well, y is going to change every time we change x, right? So if x is -1, what will y be? Well, it will be -1 squared plus 1. So this is the new -1 squared plus 1. Well, -1 times -1 is +1. And 1 plus 1 is 2. So I get -1, 2. Ooh, -1, 2 is right here. Interesting. All right, what about if you plug in 0? Let's go up here. I got a new camera, did you notice? I'm using the document camera to make the video. I'm not sure how I feel about it yet. We'll have to ask you. So 0 squared, sorry. Oop, that's not right. This is right. Stop talking so much. Okay, so 0 squared is 0. And 0 plus 1 is 1. So when x is 0, y is 1. Interesting. Now watch. What do you get when you plug in 1 for x? This is where it gets exciting. Y equals x squared plus 1. So you're going to do 1 squared plus 1. So what is 1 squared plus 1? Well, 1 squared is 1. 1 plus 1 is 2. So I get a 2 when I put in -1. I get a 2 when I put a 1 in. Awesome. This is like you have two different inputs giving you the same output. That's totally fine. That's like having two rows of Twix, or if I can press A1 and get Twix and I press A2 and get Twix, I'm good. Like we just care, we know what we're going to get. So this is still a function, right? There's only one input for 1. Okay, so then let's do the last one. X equals 2. So we're going to replace x in this equation with 2. So you're going to get y equals 2 squared plus 1. Let's put a 2 there. That's a 1. 2 squared, and you could still use parentheses if you want, but you don't need them. 2 squared is 4. 4 plus 1 is 5. Huh. Watch what happens. 1, 2 is here, and 2, 5 is here. And do you remember what this is called? You get a parabola. Let me say it again. This is called a parabola. And this is not a straight line, right? So is this function linear? No, because it is not a straight line. It's a function. Each input has exactly one output, but it's not a linear function because it is not a straight line. Sometimes I forget you're watching and I go, oh goodness, my handwriting is not so good. Pay attention. Okay, next one. Y equals 1/2 x. What do you think this is going to come out to be? Well, this one was nonlinear, so I'm just thinking. All right, -4. We're going to use this x value, and we're going to plug it into this equation and see what y is. So when x is -4, we're going to get -4. Oop, let me write that another way. Y equals 1/2 x, right? So I'm going to plug in -4 for x. Okay. What is y when x is -4? Well, what's half of -4? Negative times a positive is negative. 4 divided by 2 is 2. So I get -2. -4, -2. Then plug in -2. So happy that they use multiples of the denominator. That way I get nice, neat integer outputs. Woo! Okay. Remember we talked about that a little bit. Y equals 1/2 x. We're going to do y equals 1/2 times -2. Half of -2 is -1. -2, -1. Here you are. What do you get when you plug in 0? What's half of 0? Or what's 1/2 times 0? Anything times 0 is 0. This is looking like it's lining up so far. So then let's do 2. So y equals 1/2 times 2. Half of 2 is 1. Positive 1. We'll get that same thing going on over here. It comes out to be a different sign. Okay, and then let's plot that 2, 1. And then 4, y equals 1/2 of 4. Half of 4, half of 4 is 2. So 4, 2. My daughter used my ruler the other day. It's still in the drawer. I think I put it back. I know she didn't put it back, but I saw her using it and I was thinking, oh my gosh, it might be the last time that ruler is found in that drawer. Remember I told you this is the ruler that I've had in my drawer since I was a little kid. My mom gave me this desk when I moved into my house. So y equals 1/2 x. And it came with the ruler. It's always in here. It's so weird. All right, even with the children using it. Is this function linear? Yes, look, it's one continuous straight line. Yes, because it is a straight line. Oh, my husband's coming. He doesn't know I'm making a video. Okay. What do you notice that is different about the functions in questions 1 and 2? Well, kind of like duh, right? This one's nonlinear and this one is linear. But I think what they're really getting at is if you look at the equation, eventually you'll be able to tell without doing all this work whether or not the equation is linear or nonlinear. So this one had an exponent associated with the x, and this one did not. So this one meets the y equals mx plus b format. This would be plus 0 right at the end. And so you can see that this created all positive outputs, which is why you end up with your parabola. All right, so we're going to change things up a little bit because talking to Miss Velarde, we thought it was a little bit too much to do nonlinear in one day for you. So we're going to stretch it across 2 days, and I'm going to go ahead and ask you to try these 3 problems like we did together. So on page, what is this, 8? Can you complete 3, 4, and 5 for your independent practice? Do the best you can, and I will see you tomorrow. Have a good day.